If you're building with LLMs, you're probably obsessed with things like prompts, context windows, and performance. But what if there's a silent culprit in your code that's costing you tokens and speed on every single API call you make? It's something we all use, we all take it for granted, and today we're going to put it under the microscope.
Hey, ever look at your API bills or just feel the latency in your app? Does it seem like you're sending way more data than you really need to? Like every single call is just a little bit slower, a little more expensive than it should be? Well, the problem might be hiding in plain sight. I'm talking about the very structure of your data.
For decades, right, JSON has been the absolute king of data interchange. It's what we use for REST APIs, how we store things. It's just everywhere. But here's the catch. When we stringify a big chunk of JSON and stuff it into an LLM prompt, we're also sending all these extra characters, the curly braces, the quotes, the commas, and in the world of LLMs, every single one of those can count as a token. And tokens? Well, we all know tokens equal time and money. So, what's the alternative?
So here's our game plan for today. First, we're going to really dig into the hidden costs of our old friend JSON. Then, we'll meet a new challenger on the scene called TOON and see the kind of wild savings it offers. But, and this is important, we'll also uncover a critical weakness it has with nested data before finally laying out the absolute best way to use it to get amazing results every time.
Okay, let's start with the problem itself. Look, JSON is amazing for machine-to-machine communication, but it was just never ever designed for the unique, token-based world that large language models live in.
The issue here really boils down to four things. All that extra stuff, that syntactic sugar, the braces, quotes, commas, they're all wasted tokens you have to pay for. And more tokens? That directly means higher API costs and, you guessed it, slower response times. And hey, let's be real for a second. Have you ever actually tried to debug a prompt by reading a massive minified JSON string in your logs? It's an absolute nightmare. That terrible readability just slows down development and makes observability way harder than it needs to be.
But this is where our story gets really interesting. A new format has shown up, one that was designed from the ground up, specifically for this new AI-native world. It's called TOON.
TOON stands for Token-Oriented Object Notation. Its entire reason for existing is to be a super compact, human-readable format for sending structured data to LLMs. It's not here to replace JSON in your app's backend or anything. Think of it more like a highly efficient shipping format just for your prompts.
So how does TOON pull this off? Well, it's pretty clever, actually. It basically borrows the best ideas from other formats. It uses that clean, indentation-based structure from YAML for any nested data, which makes it incredibly easy for a person to just read. And for arrays of similar objects, it switches to a tabular, kind of CSV-like format. The whole goal is super simple. Minimal syntax, maximum clarity. And here's what that looks like in action. On the left, our familiar JSON, with all its syntactic noise. And on the right, the TOON version. Just look at that. No braces, no quotes, no commas. It's just the data presented in a clean, self-documenting way that an LLM can easily figure out.
So, okay, it definitely looks cleaner, but what's the actual measurable impact here? Let's talk about some real-world savings, because that's what really matters. The benchmark data is, well, it's pretty staggering. In one test case, a prompt using standard JSON needed 15,000 tokens. The exact same data just formatted as TOON only required 8,700. That is a massive reduction right off the bat.
In fact, when they ran a whole bunch of benchmark tests, Telian achieved an average token reduction of 42%. I mean, just stop and think for a second what a 42% cut in your input token costs could do for your application's budget and its performance.
The source material really sums it up perfectly. You can expect 30 to 60% fewer tokens. And remember, it's not just about saving money. Fewer tokens for the model to process means faster inference times, which gives you a snappier, more responsive experience for your users.
And hey, we can't forget that other benefit we talked about earlier. Because TOON is so much cleaner and more readable, it makes debugging your prompts and digging through your logs so much easier. You can finally see the data you're actually sending without getting lost in a sea of brackets and quotation marks.
Now, at this point, it probably sounds like TOON is some kind of magic bullet. But, like any powerful tool, you gotta know how to use it right. And there's a really important catch when it comes to the complex data we see in the real world.
So far, all the examples we've seen have been with pretty simple, flat data structures. But what happens when you have nested objects and arrays? Like a typical user profile that has a list of interests and then a nested address object inside of it.
To find out, we can look at a cool experiment from the source material. The test takes the exact same user data and runs it through both JSON and TOON, first in a flat format and then in a more realistic nested one. And the results? Well, they were not what you might expect.
Okay, check out this table. For the flat data, TOON is the obvious winner, right? It uses just 460 tokens compared to JSON's 757. That's the huge saving we're looking for. But now, look what happens with the nested data. JSON's token count barely moves, but TOON's, it jumps all the way up to 765 tokens. So here's the big takeaway, the crucial point. When you feed Cone a deeply nested data structure, all the indentation and structure it needs can sometimes end up using more tokens than the noisy but compact syntax of JSON. This is a super important detail that could totally trip you up if you're not aware of it.
So, does this mean TOON is only good for simple stuff? Not at all. It just means we need a smarter workflow to make sure we get those massive savings every single time.
And the best practice is actually incredibly simple. Before you convert your data to TOON, you flatten it. You just transform those nested objects and arrays into a simple flat key value structure. That's it.
This gives us a really clear 4-step playbook for getting the best performance. You start with your normal JSON data in your app. Step 2, you run it through a flattening utility. Step 3, you encode that nice flat data into the super efficient TOON format. And the final step, you send that optimized payload to the LLM and just reap the benefits of fewer tokens and faster speeds every single time.
And you know, getting started with this is surprisingly easy. Yeah, TOON is new, but it's being actively developed. There's a command line tool you can use for quick conversions, and there are already libraries for major languages like Python, Rust, and Java. Oh, and one last tip. The best way to use it is to just show the LLM the TOON formatted data. Don't describe it. It's designed to be self-documenting, so the model will pick up the pattern without you having to write some long explanation.
You know, the story of TOON is a perfect reminder that the tools and conventions we've relied on for years might not be the best fit for this new era of AI. It really makes you wonder, as this technology just keeps evolving at a breakneck pace, what other obvious best practices are we going to have to question and completely reinvent next?